This is Math 2. We are doing the homework for solving inequalities. Again, whenever we solve these, we need to graph them just to prove that we know what this sign is and if we've done it correctly. So for this number one, you're going to start by distributing the 2, and you're going to get 2x minus 14. We haven't multiplied either side or divided either side by anything, so this sign is not going to change. It's still 3x plus 14. From here, we need to choose what side is our variable side on. I'm going to choose the left-hand side here, just so I don't have to switch it later. Although maybe to explain a point better, here, let me choose the right-hand side, and I'll show you something that we talked about in class, but we should review. If I subtract 2x, and then that means I now have, those are gone. I have a negative 14 is less than x plus 14. Notice that the variables are on the right-hand side, which means these constants need to be on the left-hand side. Let's go ahead and subtract 14 on both sides, subtract 14, and now I have that inequality is still less than, there's x, negative 14 minus another 14 is negative 28. And this is usually where students are like, I think the arrow is pointing that direction, and you're wrong unless the variable's on the left-hand side. So you need to switch the variable to be the left-hand side, the negative 28 to be the right-hand side, and you can't just switch them willy-nilly. You need to go ahead and switch this sign as well. It was a less than, and now it's a greater than, and that number line should be pretty straightforward. You make a mark here at negative 28, and you make an open point because it's not equal to down here, and you say everything, and now the arrow is pointing to the correct direction. We're pointing it this way, and we say everything to the right of 28 because it says x is greater than negative 28. All right, what about number 2? I'm going to distribute yet again. This is going to be 3x plus 6. Okay, be careful here. This was the most common mistake that we saw today. This negative needed to be distributed, so it's a negative x, and then a negative 1 still is greater than 4x plus 4. Do you switch this sign? No, because we haven't done something to both sides. And that's usually something that we choose to do. Next, I'm going to combine my like terms. I see a 3x and a negative x, which combine into, maybe I'll annotate this and say these two come down into a 2x, and then I'll annotate the 6 and the negative 1 come down into a positive 5. This is still all greater than 4x plus 4. And then from here, we need to choose what side do we want our variables on. Let's go ahead and move them all to the left-hand side now and explain a different rule. So if I move them all to the left-hand side, I'm going to say subtract 4x, and notice I'm writing the variables underneath one another so they still line up. Yes, that 4x and 4x cancel out, leaving behind a negative 2x plus 5 is greater than a 4. And then from here, I need to move the constants to the right-hand side. Since the left-hand side is for the variables, I'm going to move the 5 by subtracting 5 on both sides. Subtract 5. And then from there, you're gone, and I am left with a negative 2x is greater than a negative 1. And then from here, I need to move all of you down because I need more room. Actually, I can, here, I'm just going to move up this direction, right? So usually what I do here when you run out of room is you just draw an arrow and say, okay, come up here. I am going to rewrite 2x is greater than negative 1. I have a negative 2x, sorry, if I copy it down correctly. I need to get rid of the negative 2 by dividing both sides by negative 2. Divide by negative 2, divide by negative 2. And now that I've done a negative operation to both sides where it's either multiplying or dividing, in this case it was dividing by a negative, the sign will flip. Instead of a greater than, we have a less than, and now I have x by itself on the left-hand side because these negative 2's cross-canceled. And again, on the right-hand side, I have a negative divided by a negative, which is a positive, and it's a positive 1/2. So again, on a number line, just go ahead and do a tick mark at 1/2 and say it's an open point. Again, open because there's no equal to sign underneath here, and this arrow is indicative of saying it's going to the left-hand side. Everything that is less than 1/2 is fair game, and that is our graph right there. All right, and number 3 and number 4, this was something that we reviewed towards the second half of the class. What happens if you do these with fractions? We ignore the inequalities here just to play with the fractions. The general idea behind each of these is to multiply by a number and get rid of the fractions in the very first step to make your life as easy as possible. A lot of students do not like fractions because that means you have to have like denominators whenever you have to add or subtract, and that's a lot of work. So let's avoid that work and just multiply by the same number. Like if I just multiply both sides by 100, still won't work because I need to be able to cross-cancel everything. And I need to think of what is the least common multiple of 3, 6, and 4. If you said 6, you're incorrect because 3 and 6 do go into 6, but 4 does not. The next biggest multiple there you might think is 24. It's actually 12. So if I multiply everything by 12, if I put a 12 here and multiply that by that entire left-hand side, a 12 here and multiply that by everything on the right-hand side, maybe I can do parentheses like this, you can see what's going to happen here. I'm gonna go very slowly on this one just so that everyone can follow me. I can go a little bit faster in number 4. This is going to be 12 times 2 on the top, x, plus 12 times 1 is just 12. So I'm just going to say 12 over 6. And that's going to be equal to 12 times 3 all over 4. Again, I distributed the 12 here and here, distributed the 12 over here, and now I can start cross-canceling. 12 and 3 can cross-cancel. 12 divided by 3 is 4, and then that turns into a 1. 12 divided by 6, these cross-cancel down to a 2 and a 1. This 12 and 4 cross-cancel down into a 3 and a 1. So now what we have in the top up here, we have a 4 times a 2, which is 8. So we say 8x. Then over here, just a 2, so I can say plus 2. This is going to be equal to, I have a 3 and a 3, which is a 9, is equal to 9. And notice what we have. We have an equation with no fractions. Way nicer to deal with. Right now we could just subtract 2, and we get 8x is equal to 7. And then from there we divide by 8, and I ran out of room, so I'll do an arrow up here and say that x is equal to 7/8 for our final answer, and then we box it. Let's try the same process again in number 4, but go a little bit faster. So in this case, what is the least common multiple of 5, 3, and 2? I think it's 30, because I know that 5 times 3, these are prime numbers. You usually just multiply those together. And 2 is also a prime number. These are all co-prime, meaning they don't share any factors. So you just multiply them together. So 5 times 3 is 15. 15 times 2 is 30. I think we have to multiply all of these by 30. Multiply that one by 30. Multiply that side by 30. Holy moly, that's a big number. But that's going to be... I'm going to cross-cancel at the same step. That's why I'm going to go faster. 30 and 5 cross-cancel down to a 6 and a 1. I have a 30 that's distributed here as well. So this 30 is going to turn into a 10 and a 1. And this 30 is going to turn into a 15 and a 1. Okay, so what do we have now? We have 6 times 4, which is a 24. And then I still have the x. I have just 10 here, so I'm going to write plus 10. And that's going to be equal to, I still have the negative, and then it's going to be 15 times 1, which is just 15. So it's negative 15. And now we're ready to move on without our fractions. Let's move the constants to the right-hand side by subtracting 10 on both sides. This is going to give us 24. X is equal to a negative 25. And then from there, we're just going to divide by 24, and x is equal to a negative 25 24ths. So there we go. Final answer in box. It's okay to be improper. That concludes our video. Thanks for watching, guys.